I guess I can share my screen and we can start with that part. All right, perfect. Time to go. 6 past 10. Time we have. Awesome. Cool. So thanks everyone for joining on this Saturday morning. For some might be like early morning, for some might be not that very early. But thanks for joining. So this is the last session from this mini dev camp that started on the 5th of December. So since then we had 3 sessions that we completed. 3 assignments were assigned, and this is the last session when it comes to that. We'll go back again. The host, it's Renuka, Sumit, and I. So 3 of us today to close it off this one. You have noticed in the previous sessions that some of us were not there just because we had that responsibility split between us. Before we go further or anything else, I just wanted to bring it again about code of conduct, which applies to all participants. And that can be like, be respectful, there's a zero tolerance, and you can, by the chat, report to any of us. You can just DM us directly by the chat, or you can just email us to hello@gdglondon.dev over there for any feedback you might have for this one. That's regards for that one. So as we said, today's the week 2, session 2, where we're talking about the power of Gemma. And this is the last session on that one. So I know someone asked in the chat about a recap. We won't have a recap from all of those before, for the simple reason that all recordings are made publicly. So in order for, to give also opportunity to everyone to go into details to every session that it is. It's not a longer session. Usually they are around hour something, hour and a half, between that. You can skip the talking in between in the beginning if you would like, or talking at the end and stuff like that. So you can just focus on that. But everyone, they're all embedded into the session. So starting and kicking it off today, we have Nishi, who's on the call already. Nishi is, she's well known to the London community, and we're very, very thankful for her for taking away of her Saturday time in order to talk about or unwrapping the power of Gemma. We tried to do a little bit of Christmassy on this stuff. Nishi is an architect that's published in Sapien. So Nishi, you're already on the call. You want to kick it off? I can start sharing.
Yeah. So, hello everyone. And as Quran mentioned, I work with Publicis Sapien. I'm an architect. I'm also a Google developer expert with in machine learning and AI. And today I'm going to talk about Gemma. And I'm going to specifically talk about how to fine tune Gemma models for your use cases. And the way I've kept this session, the way I've kept today's session is I'm going to walk you through the notebook, and I have I've shared a link in the chat. You can click on that link, and if you have access to Colab, I would highly recommend you to run the Colab along with me, so that you will be able to fine tune your own. You will be able to fine tune your own Gemma 2 model with your own data set, and I think that would be cooler. I've kept it less theory, more practical, considering the holiday time, and I just wanted to keep it light, like less theory, more practical, do cool, build cool stuffs. So if you click on the GitHub link, let me quickly share my screen. Okay. I hope you're able to view my screen. Yeah. Okay. So here, if you see this option run in Google Colab, you can click on this and it will open the notebook in your Google Colab, right? And then I'm going to walk you through each and every step, and I'm going to walk you through the concepts also, what fine tuning is, brief about the Gemma models, and what are we fine tuning. So I'll go through each and every step one by one. Okay. I hope you're able to access the Colab and you're ready to fine tune your own Gemma model along with me. So, first thing first, there are few prerequisites to run this Colab. The first thing is, because we are fine tuning a model, we would need a GPU in this scenario. So in this Colab here, you can change your runtime, and if you click on change runtime, you can select a GPU over here. This is available in the free tier of Colab. So just change the runtime, select T4 GPU, click save. So yeah, this notebook of yours will use a GPU while we are training the model. That's the first prerequisite which you need to do. The second prerequisite is, we are going to use the Gemma model from Kaggle. We are going to download the Gemma model from Kaggle site. So if you go on to Kaggle, if you already have an account, great. If you don't have an account, you would need to create a account on Kaggle. And when you visit Kaggle, you need to agree to the license of Gemma, which basically says that you're not going to use Gemma for any bad purposes. So just agree or consent to the license of Gemma over here. Go to Kaggle, search for go to Kaggle, go to models, and in the models you can search for Gemma, and here you should have an option to consent. Hope uh, it's all clear till now. Then the third step is, you would need your Kaggle username and the key. So if you click here in your profile, go to your profile, and oh, sorry, not your profile, it's in your settings. And if you click here, create new token, it will create a new token and it will download a JSON file. That JSON file will have your username and your key. So you need to take your username and your key, and in your notebook, you need to add your Kaggle username and your Kaggle key over here. Okay. Hope it's clear till this point, right? You all. So what we are going to do now next is, uh, once we basically fine tune a model, we are also going to deploy the model to Kaggle and Hugging Face. You can skip Hugging Face, or I mean, that's up to you whether you want to publish it on Kaggle or Hugging Face or both. So if you want to publish it on Hugging Face, you would need your Hugging Face user as well as your token. But I'm skipping this for now. Let's just focus on publishing it onto Kaggle. Okay, so those are the prerequisites to run this notebook. Uh, and now let's get started. So first thing first, what's fine tuning? What is fine tuning? So fine tuning is basically, it's a form of so basically your large language models, your foundation models, they are trained on vast amount of data, and during that training phase, your model has a basic understanding of the language. So it understands the language and it can perform so the basic task which it performs is sentence completion. So if you give a model the cat sat on, it will try to predict the next token for that particular sentence. So it would predict the next token as stable or something. But like, it is not fine tuned for a particular task. Okay, it is a general purpose model which understands the language. Now fine tuning comes into picture when you want your model to perform tasks particular to a domain, or you want the model to perform uh, to full to fulfill some instructions. So there are tuned models. Like Gemma also has an instruction tuned model which is tuned uh, for conversations, so that the model can have a conversation with a user, effective conversations, right? So how does the fine tuning works? Fine tuning, it basically leverages transfer learning. Transfer learning is basically the knowledge which the model has gained during the pre training process. that knowledge, we use that knowledge and we fine tune that knowledge uh, as per our requirement. So you can fine tune your model for, let's say, an example of medical diagnosis. So you have a huge amount of data of medical diagnosis and you want to train a model which can basically suggest a medical diagnosis based on a symptom, right? So you take that data, you take your foundation model, and then you fine tune that model using that data, right? So that's where fine tuning comes into picture. Okay. Now, there are alternatives to fine tuning. And one such alternative is RAG, which is retrieval augmented generation. The difference between fine tuning and RAG is, in RAG, you provide additional context to the model when the model, like when the model responds to your query, it uses that additional context to respond to your query, uh, and that's done at the inference time, right? So during the inference time, you fetch the relevant context from some database, you provide that context to the model, and then the model uses that additional information to respond to a query. That's RAG for you. But fine tuning is basically the model learns through that data, so it is in model's memory. So you know the model is more efficient, it is more accurate, right? So one alternative is RAG. You should use RAG if your data is continuously changing, and if you're okay with like a slightly lesser accuracy, fine tuning provides you more accurate responses, less hallucination. So if your data is not changing a lot, and your use case is basically, oh, sorry, yeah, your use case requires more accuracy, stick to fine tuning. And if your data changes a lot and you're okay with like a medium level of accuracy, go with RAG. So that's about it. The another alternative is basically prompt engineering. You give some instruction to the models. The models nowadays are well trained to follow the instructions. So some of the tasks can be achieved using prompt engineering. Like the example which we are going to take today can be done using prompt engineering as well. But for the sake of learning, we are going to do fine tuning and understand how fine tuning works, right? So what we are doing in this notebook is, we are going to fine tune a model to generate a title in a particular language. Now this notebook basically generates title in Portuguese language, but you can try your own language. You can create the data set in your own language, and I'll walk you through how you can create that data set for yourself. Okay, so moving on, uh, the initial setup that I've spoken about. So you need to set your Kaggle username, you need to set your Kaggle key, and then this particular line is going to connect your notebook to your Google Drive. So I'm going to run it along with you, and okay, it needs access to all my keys. I need to provide, and then it is asking me to connect to Google Drive. Now, why is it asking me to connect to Google Drive is, so once we train the model, your model will be saved on your Google Drive, and then from there we are going to upload the model onto Kaggle and Hugging Face. Okay, so I'll let this run. Yeah. The next thing is, we are going to use Keras and Keras NLP. We are going to use these two libraries for training our model. Keras is a famous library for natural language processing related task, and it supports multiple frameworks such as JAX, TensorFlow, PyTorch. It is built on TensorFlow. So here, if you see, we need to define our Keras backend, that is JAX. JAX is recommended for Gemma because Gemma has been trained using JAX, and that's the recommendation. So if you are working with Gemma models, set your Keras back into JAX. Then the other thing which we need to set over here is the memory fraction. So memory fraction we are setting here as 1, which means that all the available memory is going to be utilized by this by this notebook to train your model. Right. Then we import our Keras NLP module, we import the Keras library, and these are the training configurations. I'll get to this later when we are actually training the model. The model ID is Gemma to instruct model. So we are using Gemma to instruction tuned model. We are not using the pre-trained model. We are already using a fine-tuned model, which has been fine-tuned, um, which has been instruction tuned basically. So this model is, you can chat with, using this model. So this model is capable of having a conversation with the user, right? So let's quickly run this. I'll quickly check if there are any. You should be able to use Jax backend, but your model should support it. Can you briefly also say how to run it in Kaggle directly? Okay, I will touch upon this later. Okay, cool. So this is just doing the installations. Moving on, why fine tuning? So I've touched upon this a bit, like why would you use fine tuning? But depending on your use case, I would suggest try prompt engineering first, try RAG first, and then I would say go for fine tuning, because fine tuning is an it's a meticulous process. Like, you have to collect the data, you have to clean the data, and then training requires compute, it requires resources, right? It's an expensive process. So only go for fine tuning if it is absolutely necessary. There's no need to fine tune a model if you can, like, prompt, you can give some instructions to the base model, and your model is capable of, like, capable of using those instructions, and that works for your use case, right? So try those things out, and if you think that fine tuning is absolutely necessary for your use case, go for fine tuning, right? So we have installed our modules, we have imported the Keras library as well. Now moving on, we are going to download the Gemma to instruct model from Kaggle. So this line basically is going to download the instruct model from Kaggle, right? If I run this, this is going to give you a summary of the Gemma to instruction model. So meanwhile this runs, I'll quickly go through this bit over here. So there is a way where Gemma processes the input. So you need to define input in this format. So this is basically telling the Gemma model that this is the start of your user prompt, and this is your input comes over here. So you define user and then prompt, and then this basically tells the model that this is end of your user prompt, and then again there's a start, and it starts with model. So this basically tells the model that, okay, now next I have to complete particular uh, this particular statement. So your input has to be in this format, you have to use this template for any kind of training which you're doing on Gemma models, right? Uh, then here is some information about your Gemma model. So Gemma tokenizer has a vocab size of 256,000, and then here it gives you the parameters. So we are using Gemma 2 billion model, which has basically, these are the number of tokens, number of parameters which Gemma 2b has. Okay, so total parameters are this. These are the trainable parameters. And the total size of your Gemma 2b is close to 10 GB, right? Okay, so moving on, we are going to now see how the instruction tuned model works with these prompts. So we are giving it 4 prompts. First is, we are asking the model to translate the text to Portuguese. Now the Gemma models are trained Like they are not specifically trained on different languages, but the data which has been used to train the Gemma models, that data had data from different languages. So the model understands various languages. So if I run this, the model will be able to convert this text into Portuguese, right? It is going to take a couple of seconds to generate the text. Uh, so what we are going to do in this notebook is we are going to fine tune the Gemma model to generate a title in a particular language, right? So if you see over here, for the first prompt, it is able to generate the text in Portuguese. Then the second prompt is speak like a pirate. It is able to speak like a pirate, ahoy, matey, and like you can read that through. Then we have asked the model to write a title, and then it is asking us to give some more context on like what kind of title you want, and then it has given you some suggestions. Now we are going to train the model in such a way that if we prompt the model write a title, it gives you a title in your own language. So for me, I'm going to run this notebook, I'm going to give the data in Hindi because Hindi is my native language, I understand Hindi. So I'm going to use Hindi as my data set. And when I prompt the model write a title, it will give me a title in my native language, Hindi. Okay. Then the last thing, we have asked the model to write a poem, and it has written a poem for us. Okay. So let's get into the fine tuning process. Now, the first step of fine tuning is tokenizer. So your input, you need to tokenize your input data. So tokenization is a process where you convert your input into vectors, because your model understands the vectors, understand numbers, they understand vectors, right? So you have to convert your input data into a format which the model understands. Now, in case of Gemma, Gemma tokenizer is based on sentence piece. You can check out how the sentence piece tokenizer works. I'll quickly show you how it tokenizes the input text. So here there are two examples, one in Portuguese and one in Hindi. So the tokenizer which Gemma uses, it can tokenize inputs from various languages. And you see over here, it has generated a vector for both of your inputs over here. And if you see, you can also see like token wise what the value is. So the value of your like how the tokenization works word by word, you can see that over here, right? So you can give this a try in your own native language and see if Gemma works for your language and how well it works. Okay. I hope it's clear till this point. And next, we are going to create our own data set. So okay, I'm going to come to all of these questions. Okay. So loading of the data sets. Here, if you see the data, this is all Portuguese titles. We can quickly generate a data in our own native language using Gemini. So I can quickly go to Gemini and ask it to generate a list of titles in Hindi. Oh, okay. Oh, okay. That was strange. Oh, sorry, my bad. Titles, okay, book titles and 20. Yeah, and we can just copy this into our notebook quickly. And I would suggest you also to create your data set along with me. and see how that works. So we'll quickly copy paste all of this. Okay, I am going to quickly format this. I thought I already, actually, I've already done this. Yeah. So let me just copy. No. Okay. Just bear with me for a second. And the thing, if you notice over here, is we have just taken like 20 examples, and that's the power of these models. Like they start learning with such minimum amount of data. Uh, Obviously, the results which we will get would be repetitive because the data set which we are using is very limited. For better results, obviously, we need to create a large data set and train the model using large data sets. Okay, that's done. And I'm going to run this, and then I'm going to walk you through. Okay, and this. Yeah, should work fine now. Okay. So yeah, if you see over here, the training data also we have created in this format. So we have added, this is basically like giving telling the model that if the user gives a prompt like write a title, then the model will generate a title like this. So this is how we train the model, and this is our training data which we are going to use uh, to train in the later step. And you can just quickly have a look at how your training data looks like. Right. Now, this example, obviously, we have taken a very simple example over here. You can also train the data on different use cases. Like you can get data, you can pick the data sets from Hugging Face, and here is an example of how to uh, use the data from a Hugging Face data set. This is commented out, but you can uncomment and you can use this data as well. What this is doing over here is it is basically we are creating a data to fine tune a model where we want the model to generate an email, generate a response for a generate an email for a Korean cake bakery. So they have taken bunch of emails in Korean, and then they use those emails to fine tune the model so that the model understands the tone and then uses that tone to basically respond to emails. So you can give this a try, and you can try with different data sets which are available on Hugging Face. There are customer data sets as well which you can use, and you can train Gemma models using those customer databases, and you can create a customer chatbot out of those. So do give this a try. I'm going to skip this step. I'm going to move on. And Now we are going to understand what fine tuning technique we are going to use over here. And then we are going to fine tune the model. So we are using the LoRa fine tuning. There are different techniques out there for fine tuning a base, fine tuning a model. Uh, a simple fine tuning technique would basically update all the weights which are available in a model. So as you have seen, Gemma 2b has like 2 billion parameters, right? It has close to 2 billion tokens or 2 billion weights, right? So if we try and train all those weights, if we try and modify all those weights, that would need a lot of time and lot of resources. So that's why we are using this low rank adaptation fine tuning technique. What this technique will do is whatever the pre trained weights are available, it will freeze those pre trained weights. Okay. And it's going to freeze those pre-trained weights, and we are going to train a new set of weights, a smaller set of weights, and we are going to add those weights on top of the pre-trained weights, right? So we are just going to train a small set of parameters. Okay. And how that works is, so uh, just the basics of how the matrix multiplication works. So if you see over here, your the pre-trained weights are of dimensions d cross d, right? So let's say the value of d over here is 700. So your pre-trained weights would have dimension of 700 cross 700, which would be equal to 4,90,000 parameters, right? Now, what we'll do as part of low rank LoRa is we are going to select a rank. So, and so when we are adding a set of these weights on top of the pre-trained weights, we need the matrix which we are going to use should be in the same dimension d cross d, right? But how are we going to uh, define those matrices, right? So that's where the parameter rank comes into picture. So we are going to select, we start with a low rank. So we start with a rank of 4. Now, if our dimension is 700, we would create a matrix of 700 cross 4 plus 4 cross 700, right? So that is basically training parameters of what, 5600 parameters. That's what we are going to train as part of your LoRa fine tuning technique. And then we are going to add those parameters on top of the pre-trained weights. I hope that makes sense. So in case of Gemma 2B, if you see, Gemma 2B has 2 billion parameters, and using LoRa, we are just going to train like around 29 to, I think this is 2 billion, 29 lakhs. Yeah, this is like 29 lakh uh, at parameters which we are going to train. So we are going to initialize, we are going to enable LoRa over here, and we are going to define the rank over here. So we have taken the rank as 4, right? And then we define the sequence length. So this token limit we defined initially. We have defined the token limit of 128 uh, just to control the memory usage. Then we define the learning rate. Uh, and then here we have defined that when we are calculating the loss, we are using the sparse categorical cross entropy. Okay, so these are the configurations which we have done for fine tuning the Gemma model using LoRa technique. Now, we are going to create a folder named Gemma Workshop in our drive, and that's where your model will be saved. Uh, One quick thing over here is we have defined a custom callback, and on this callback what we are doing is at the end of each epoch, whatever the weights which are generated, we are saving those weights in our drive. And here we have defined our training epoch as 5. So that means the training process will run 5 times, and each time after each training process, like once like after each training process, the weights are going to be saved in your Google Drive. And this is basically plotting your loss function over here. uh, I should actually run this because it's going to take a while to run. I'm going to run this, and I'm going to, okay. So after each training set, we are going to also see how the model is behaving. So after each epoch, we ask the model to generate a title and also write a poem. And we'll see how the model learns and after each epoch. All right. And yeah, I think this is just a basic information of the Gemma model. And you can see over here, it has frozen the initial pre-trained weights, so they are non-trainable. And these are the parameters which we have trained, which we are training right now. Okay, this is going to take a couple of minutes. Meanwhile, I can actually take some questions. Okay. How do we calculate how much compute is required based on LoRa rank, a number of parameters? Uh, uh, I would usually like give it a trial and error. I am not exactly sure you would how you would be able to calculate the exact compute. It's usually when you define your pipelines. Usually, it depends on your cloud provider, and sometimes your cloud provider takes care of all these things for you. So I would leave it with the infra setup. Uh, Tokenizer and embeddings. So yeah, embeddings captures your captures the semantic relationship of your input. It is similar tokenizer is It is similar to embeddings, but embeddings also have the positional value plus your it also captures the meaning uh, into it. And yeah, so embeddings are we need to generate the embeddings to train the model, and those embeddings are provided as an input to your model while we are doing the training process. Benefits of adding the time lapsed and what other timings are useful. So we added time lapse just to understand how much time the model is taking, what's the inference time, and like how does the model behave before fine tuning and after fine tuning. So usually when you fine tune a model, the inference time doesn't change much. But in other techniques, like if you do RAG, or if you are using any other technique, right, if you're providing additional context to the model, that basically adds on to your inference time. So that's basically for you to compare which technique is best for your use case. Okay. So it started training and generating responses from each epoch. So if you see, after the first set of training, the model did not learn much. And when you prompted the model write a title, the model did not generate anything. And as we know that the model was anyways able to write a poem, so it has written a poem over here. Then from in the second set of training, it was able to generate a title in Hindi. So when you prompt it write a title, it was able to generate a title in Hindi. And write a poem is fine, right? So you can see the output after each epoch over here. It was able to learn from the second epoch itself, which is great. The only problem here is it is using the titles which we provided in the data set. Because our data set is very small, it is not generating any new titles. It is just using that data, and it is responding using the same data. If you want the model to generate new tokens, you will have to use a bigger data set, like probably a data set with thousands of records. And also in some cases, like if you see the example of the Portuguese one, which was originally there in the notebook, because the model is familiar with Portuguese language, it after like fourth epoch, it started writing the poem in Portuguese language, which which is something which may work in favor of your use case, or which can also be a negative point for your use case. So that's where you would figure out how many epochs you need. And you can probably use the weights which is generated after the fourth one, and ignore the weights which are generated after the fifth set of training. So you can play around with it depending on how the model is behaving. Right. Then also a quick thing over here is you can also share. So we have saved the weights in our Google Drive, right? you can share those weights with anyone, and they can, and you can basically use those weights on top of your instruction tuned Gemma model, and then start using that. Like, you don't have to go through the entire process of training. You can just share those weights, and then you can enable those weights on your model and then start using it directly. So this is a code snippet for that. You can give it a try in your own time. Now we are going to see how the model behaves over here. So just a quick thing to note over here is we have changed the sampler technique to top K. The normal sampler technique which the Gemma model uses, greedy sampler technique, which is basically it will always give you the same response. So it uh, responds with the token which has the highest probability, and it always responds with the same, with the token which has the highest probability. So if we don't define the sampler top key over here, all of this will basically give you same response. And we want some random responses. That's why we have changed the sampler to top K. So if you see over here, first two time it has generated the same response, but then uh, for the next three one, it has given you different titles. And these titles are from your data set only. It is not generating anything new because our data set was very limited. Yeah, if I check, I'm not sure whether it will. Uh, okay, sorry, I think something's wrong. Okay, yeah, I think it. Yeah, this is the one which it generated. But you should give this a try with different kind of data, and see how the model behaves. It actually works really great if you provide a large amount of data, like thousands of records. If you provide, it actually works really well. So we can try a different prompt as well, and it's going to give you a title. So that was all about like fine tuning Gemma with your own data sets. The next thing is publishing your model. So this step basically takes like, it takes around 10 minutes for this to uh, download the model and save your model into this folder, because it is going to be like a 10 GB. The model size would be around 10 GB. So this step takes time. You can run this and like check this after 10 minutes. It will download your model, and then you can specify your Hugging Face username and token, and or your Kaggle username, and then it will publish your model onto Kaggle. So I have published my model onto Kaggle. I can quickly show you. Um, okay, if I go, sorry, yeah. Um, should I? Yeah. Okay. This is this is the one, and yeah, this is the name which I gave. You can see if someone has downloaded your model. No one has downloaded it yet, and then you can see the configurations over here. And yeah, so give it a try. Uh, all right. So were you able to train your model with your data set? I would, yeah, I would like to know if you were able to, like, if you trained it with your in your own language, and how did the model respond? or if you faced any challenges while running the notebook. No. Okay. I think that was it from my end, and I am open to questions. Also, one quick thing over here is you can see how much memory this is using your Colab. If you see over here, it was using 13 GB. So you can see the resource utilization over here. Yeah, that's a 2B model. Yeah. So you can also try this using a 7B model. The only thing is 7B model is going to take a lot more time and would need more compute. So you would not be able to run the free tier version of Colab using 7B. So I would suggest if you want to do that, you should probably give it a try in Vertex, or use the enterprise Colab.
All right. Anyone has any other questions for Nishi? If anyone wants to unmute themselves, you can just press on the raise hand, and we'll be able to give you the opportunity to ask questions as well live. If typing is too much, I think that just went great. No one has any questions. Everything is clear.
Well, I want to hear if you were able to like fine tune a model.
I think probably most of them were just paying attention. So
Yeah.
Yeah,
maybe
yeah. I
we'll
think
be.
it takes. Yeah, I was trying to, and it takes time, no? So
Yeah.
you had all the things cut out, just like the presenter does it in the and in the recipes kind of thing. It's like everything is cut for you. So when I was doing it, I was already stuck in step number three. But
Oh, okay. But I want to know where you were stuck.
no,
Like
no.
if
So
if
it
you were
was
facing
that
any
thing that you
issues.
did with Google Drive and the keys. Yeah, so
Okay.
I'm reading and going through this right now. Yes, I'm
Oh,
reading
okay.
line by line and going through the
Oh,
steps.
okay. Okay. Okay.
That's
There's a couple of questions in the chat. One is about Gemma 7B.
7B quantization. You can fine tune a model, and then you can use quantization techniques to like reduce the size, and you can use those models on. So yeah, one of the good use cases for fine tuning is like you can download the model and then you can use it on your device. So 2B 7B models, you can use it on your edge devices, like you can use it on your phones, tablets, and that would work offline for you. So yeah, you can give that a try.
Someone got errors. If you want to expand what errors you got,
Yeah.
maybe we'll try to give pointers. Or you're looking at doing it independently after the event and just go through it
Yeah.
from the beginning.
Also, you can you can use the Gemini option on the collab. Can quickly show it to you, but that really helps. So if you go here, just put your error into Gemini, and it gives really good suggestions. So try that out. Um, but
Looks
yeah,
like we're not needed.
uh, Nishi. Apart from Google, if you want to use everything open or free, what
yeah.
can we do? So
You can
the
use
gem.
Llama models.
Okay.
Yeah. So you can do fine tuning on Llama. Llama also has a 7B version, so you can use Llama 7B to fine tuning. And I think, not sure about Fee 3, but yeah, there are a bunch of open source models available now. Oh, nice. Alexander said he got it working using Spanish, so that's great. Uh, can you explain a bit more on 403 client error on loading? Which step was it? Might be able to help you. I am not sure of that. I'm not sure whether Llamas would support Jack's backend and fine tuning with Keras. I've tried it using a different library. So you can use TRL for supervised fine tuning. So I've used those for like Llama and for other models.
All right, awesome. I think
Okay.
if and Noah has any other questions, we can. Oh, okay. So it looks like the photo 3 error refreshing Kaggle token worked. So okay,
Yeah. Cool.
cool, awesome. Sounds good. I'm gonna start sharing. Nishi, thank you very much for your time
Thank
today.
you.
If anyone
you.
does any fine tuning and published it, I'll
Yeah.
ask everyone, just let us know. We'll forward that to Nishi for a feedback as well, so that she can, have a look into it. So sounds
Yeah.
good. Thanks very much.
Thank you.
I guess we can continue on the part. So I'm gonna reshare my screen, and we are at the interesting section right on it. So continuing on that, we have. Before we continue and go to the next steps about the assignment part and everything, does anyone has any question? I think we managed to answer a couple of them from the beginning, such as um, not really, like if the if the assignment deadline passed, you won't get kicked out from it. You can still continue to do it. So please do, continue on that one. We are flexible on that side, so it does not mean that if until, like, let's say it's until 12 o'clock and it's 12:01 and we'll probably rejected it or anything like that. No, nothing's like that is going to happen. We're quite flexible on that side. Um, if you have already applied for Cloud Skills Boost from the previous sessions, you don't need to apply again, for example, today. You already have access, and you will have access throughout the whole journey on that part. So going further, for the next assignment, we know it's coming Christmas time, it's coming festive time. So there's a lot of things going on. So what we've decided is that we discussed before to have the 7 days after each event to be the deadline. However, today's one will be January 1st. So you will have up until end of the year to complete the assignments from today. So that will give you a good, there's like over 2 weeks, time that you can complete and stuff like that. In addition to today's assignment, we have assigned as well the professional machine learning engineer path as well, as part from the from the Cloud Skills Boost. So what that means is that if you do complete all 4 of the assignments and you want to go and use your time off, or whatever it is you have, during this time, that you want to go and work on the professional machine learning engineer path, you can go and you will have access free of charge, same as the assignments that are assigned right now. So the Cloud Skills Boost, for anyone that does not have access, you can, or is like for the first time joining today, you will need to use your full name as it appears on the platform. Just go to gdg.community.dev on profile, and then you will need to add the email in our form. The form is here for the ones that did not have access to it. I will repeat myself and added it into the chat again. So the assignment for this time is a generative AI for developers learning path. So it is a little bit of an advanced one. It has 12 activities. So that's why you will get to have like more time in order to do this. And although it has 12 activities, those 12 activities are not that long. However, because it's an advanced level, it might take a little bit longer on some of the activities and stuff. We will, as always, once the recording is up and running on our page, we will embed it over there, and we will share the link to the assignment after this. So deadline is end of the year, but also we have added the professional machine learning engineer path on Cloud Skills Boost. So we will share the link in that one as well. That is optional, but there is like a lot of details that you need to go through and stuff. And if you are willing and you want to expand on your knowledge, please feel free to use this opportunity for that. On the question, where do I see the credit? So there is not a shared credit pool assigned, but the paths are subscribable free of charge for you. What does that mean is that when you go through the paths, even though you're presented sometimes with 5 credits that you will need to run this lab, and you have a 0 credit under your profile, you will get to run that lab free of charge, because that is subscribable to the, well, it's not a shared credit pool, but it's to the Cloud Skills Boost shared group. So there is not the amount of credits, but there is a subscribable paths. Anything that's not on the subscribable paths and you want to, that's like outside of this mini dev camp, it will be chargeable. So just because it's not covered during this one. So yeah, those are the 2 differences on that side. Again, if you did have the form completed from before and you have access, you don't need to complete again. And yeah, that's everything that I wanted to add from our side. As always, feel free to reach out at hello@ggLondon.dev. Today is a little bit shorter session. So just want to take this opportunity to wish everyone happy learning. Wish you have a great time during the Christmas period and the New Year. Hope you're gonna have a good wind down with the family, friends, everyone that will be surrounded around you. Sumit, anything from your side?
No, I think it was a quick, good journey we had closing the year. I really appreciate the ones who are actually giving their time to make it worthwhile for us to bring these amazing speakers. And thank you for all our speakers to actually put in effort and then help all the attendees also. So definitely. It's not over, so you got assignments. You also can revisit all the videos. I do that myself. I'm going to complete this assignment from Nishi. It looks good, and I think there are different use cases that comes into mind when you're thinking of it. So Nishi gave us interesting ideas, like you could actually do some cookbook or a recipe for a particular thing that you're thinking of, some variety. So and for Christmas, I do something different. I don't know if many Indians in here or not. Instead of creating a cake, I do gajar halwa. Yeah, so which is carrot cake or carrot halwa. So I'm gonna check with AI this time to say what other variety can I do for my Christmas carrot halwa.
Nice.
So, but yeah, thanks everyone for joining, and we see you on the other side of 2025.
Yep. Thanks everyone. And we just one last thought as well. I have contacted this Cloud Skills Boost team, or like the Google Cloud team, to let us know up until when we have the access on that free. So we will be sharing that as well once we have those details. So anyone that did not have time or anything, to complete during the time period, you will still have hopefully access after the new year as well. So we'll get on those details and those opportunities. So Merry Christmas, Happy New Year, everyone, and thanks very much for being in this one. And we'll see you in person or online. Well, shortly we have another event where Sumit will be, but with myself, I hope to see you after the new year. Take care, everyone.